We are discussing convection, as Ian points out. That's whatever that means. It's one of the most important things that we deal with in the magnetosphere. And we have a little device on Atmosphere Explorer, which has been up a month now, which I think is going to measure convection rather well. The initial indications are that it will. Unfortunately, the first AE orbit has a 68-degree inclination, so we're not going to go over the polar cap and things like that very well. But it does go above the cusp, and in some longitude regions it will get up into the reasonable region where you want to look. The next satellite will be a polar one and should provide information on that thing, on the total convective pattern, I believe. You mentioned something about the diffuse aurora and its relationship to the plasma trough.
Right.
And I thought you said that it might coincide or something like that, but I think I don't know if you agree with this or not, but there's a fair amount of evidence, in fact, that the equatorward edge of that plasma trough coincides with the lower boundary of the diffuse aurora. That's a real firm identification.
Yeah, that's the real problem is to decide what the distribution of electric field is around the diffuse aurora. And you see frequently very sudden expansions of the diffuse aurora, tremendously equatorward. I mean, well beyond what you'd normally ascribe to the auroral oval, simply because it's very difficult to see the diffuse aurora from the ground.
Well, when it's pretty messed up, if you want to go back in the midnight section. But on the flanks, really, it's pretty clear, I think, that the...
Well, maybe the midnight sector that's important, not the flanks. That was the point I was trying to make, that if you have a very sudden equatorward expansion of the diffuse aurora, you may miss it on all of the optical techniques, and yet that is essentially compressing an enormous area of the night side.
There's another signature that's actually right in there that Peter was discussing the interaction of the hot plasma and the cold plasma. Whatever it is, it heats up the plasma that's associated, I think, with red arcs. There is also observed, and I'm afraid I have a lot of these observations, I haven't published them, but there are some others that have been put out at meetings, I think. There's oftentimes a very drastic increase in the plasma temperature, the thermal plasma temperature, as you go out this way again, right at the edge, right inside the edge, I suspect, of the plasma pause. Yes. And perhaps extending, we don't really know that boundary that well to tell you exactly where it is, but right across that boundary. But when you get out into the plasma trough, beyond the plasma pause, the temperature of the plasma really drops dramatically before you get to the soft auroral zone or whatever.
Drops or rises?
It drops.
So the temperature is high here and then low out there.
Yes, you have a very steep temperature bulge here. This is without any conjugate photoelectron in it, which is another effect. There is definitely some kind of heating right here that comes back down, at least in the ions, before you get to the soft auroral zone there at the edge of plasma trough.
Inside the plasma trough.
Well, all I could say is that I would say that it coincides pretty well with this boundary that Peter's shown right here. It's cold on the outside of that, and it's generally cold on the inside of that. And I think that there's a lot of other evidence.
Inside or outside?
But near that boundary, and I don't really know whether it's outside the boundary or just inside the boundary. Oftentimes it's fairly spread out, particularly down inside, I know.
You've already seen a couple of slides of the AEC data and our flow patterns that we think are in the polar cap. I should point out that the displacement of that small region,
who is that guy?
The plasma then expands over the polar cap, was displaced over to the afternoon side, and that displacement depends on the direction of the interplanetary magnetic field, just as the strength of the electric field that Canet and people saw depended on the interplanetary field. So that region moves over to the morning side if the interplanetary field would become dusk to dawn instead of dawn to dusk. The other comment concerns this slide here. The slides that Ron Burris showed were cuts across almost parallel to the dawn-dusk plane, and then we see clearly defined reversals. One of the requirements which Pat and Tom need is some sort of electrostatic turbulent field in their region where they have the diffusion of particles, and we do have passes that go through the region where all this thing happens, and you can see, the slide sort of speaks for itself. It surely is turbulent, and we really don't know what's going on there, and it could be that the small region where the plasma expands across the polar cap is there's maybe this merging thing, and then way out in the flanks or wherever it goes when it gets to the magnetopause, you see the signature in the ionosphere looks like this, like that for these regions. And we're starting to look at more data like this, but this just gives you an example of what you see if you actually go fly through the auroral oval, if you like, or through the auroral region where things are not quite so well defined. Well, while we're making the transition, the first speaker was Bill Hanson. I'm not sure who the second one was. Bill Hanson made two comments. One, the first was at the first meeting we're here to discuss convection, whatever that is, or whatever that means, I think is what he used, expression he used, and my task is to see if I can enlighten you on what that means today. The second was a remark about a little device that he flew on Atmosphere Explorer,